Good morning, students. Now in this class, we introduce two more formulas. Okay, important formulas. The first one is integration by parts. The name of the formula is called integration by parts. Suppose the integration is of the form integration of u dv. One term is u and another term is dv. The formula of this integration of u dv is equal to uv minus integration of v dv. The integration is of the form one term is u and the remaining term is dv. The formula of integration of u dv is equal to uv minus integration of v into dv. Integrating a dv is nothing but v. So this formula is called integration by parts. Actually, it's a single integration. We split into two parts. So it is called integration by parts. Another one is important is a Bernoulli formula. The inverted name is a Bernoulli. So this name formula is called a Bernoullis formula. LHS is same integrating of u dv. And whose RHS is going on u v minus u dash v1. The sign will go alternate, positive, then negative. Here u dash, then u double dash and v2. The next term plus, so minus u triple dash v3 etc. is going. You see in both the two formulas, LHS are same, but the RHS are varying. Here you know very well, dash, double dash, triple dash, all are indicating the differentiation. So the differentiating of u with respect to x is u dash. Differentiating of u dash with respect to x is u double dash, triple dash. And v, v1, v2, v3 all are indicating the integration. U dash, u double dash all are differentiation. V, v1, v2, v3 all are indicating integration. U dash, u double dash all are differentiable terms. V1, v2 all are integration terms. The integrating of v1 with respect to x is v2. The integrating of v2 with respect to x is v3. Okay. When we use this formula, suppose our given sum contains one x power, for example, is 5 and e power 3x into dx. Suppose the question is evaluate. The question is of the form, then we use a Bernoulli formula or integration by parts. You will take that first term is nothing but u and all the remaining terms are dv. Now you see exactly it is of the form integrating of u dv. So the integral is of the form one is x power and another one is e power something, or one is x power and another one is it may be a sin x or cos x. We using this formula, then the answer will come easiest. So we do the another method is also possible. You go use a substitute method or any method. But this formula is used, then the answer will come easiest. So now we see in this type of sums, we do these two formulas. Is our choice. We use the first one or second one. It's better to use the second formula. In one or two sums, there is no chance to solve in Bernoulli. Then we use this integration by parts. Okay. The important, we will take the value of u is vanish some differentiating of 2 times or 3 times. Suppose we change, it is a value of u and it is a value of dv. When we integrate one term, the power will be increases. The integrating of x is x square by 2. The integrating of x square is x cube by 3. So the power is increases when integration. The power is decreases when differentiation. Because x power n formula is n x power n minus 1. The differentiating of x power 5 is 5x power 4. Again, x cube, x square, the power is reduced. then one certain stage, one constant will come, the differentiating of the constant is 0. So when we select in integration, maximum 2 or 3 times differentiation, the term will be vanished because this formula is goes up to infinite. Suppose we interchange the terms, this process is goes up to infinity. So in shortcut form we say some x power term is always will be taken is u, and all the remaining terms will be taken is dv. Now using this formula we solve this sum. In exercise 11.7 you see the question. I integrate the following with respect to x. So the word using Bernoulli, using integration by parts is not given. We understand depending upon our given sum. Now we integrate the term with respect to x. Now we solve the first one. Integration of 9x e power 3x into dx. Now we integrate the term with respect to x. Now you see exactly one x term, one e power term. In shortcut form we say in integration some x and e power something x is there using Bernoullis formula. So first I write the formula. By Bernoullis formula, integration of u dv is equal to uv minus u dash v1 plus u double dash v2 minus etc. is going on. Important to take the value of u. What is LHS? Integration of u dv. So one term is u and all the remaining terms are dv. So I will take 9x is the value of u. Because one time a differentiation of x is 1, again we differentiate we get 0. And all the remaining terms are, because our LHS is u dv. So one term is u and all the remaining terms are dv. So I will take the value of u is 9x and all the remaining terms are dv. Here u is equal to 9x. I will take the value of u is 9x and all the remaining terms are dv. dv is equal to e power 3x into dx. In RHS, what are the terms are required? uv, u dash v1, u double dash v2. U dash, u double dash all are differentiation. V1, v2 all are integration. So first u dash. What is mean by u dash? The differentiating of u with respect to the RHS variable. Here the RHS variable is x. The differentiating of u with respect to x is actually du by dx. In another way we write it is u dash. What is the differentiating of 9x? In 9x, 9 is a constant. The differentiating of x with respect to x is 1. So u dash is equal to 9. What about u double dash? 9 is a constant whose differentiating value is 0. So the formula is top up to u dash. U double dash, then all their values are 0. Next, dv is there but we need v. In dv is there, how to get v? Taking integration on both sides. So the next step is taking integration. You know very well, integration of dv is nothing but v. Integrating of dx is x. Integrating of dy is y. Integrating of dv is v. The integrating of e power 3x is, we need integrating of e power 3x. So first e power 3x integration is e power 3x. Again, in denominator, we differentiate the power with respect to x. What is the power? 3x. The differentiating of a 3x with respect to x is 3. So is the value of v. We need v1 also because in u double dash value is there. So the next step is we need v1. Actually, what is meant by v1? v1 means the integrating of a v with respect to x. For your understanding, I write elaborate. First 1 by 3 is a constant, I will take outside. Integrating of e power 3x into dx. 1 by 3. What is the integrating of e power 3x? Again, this is the same. E power 3x by 3. So the value of v1 is e power 3x by 3 3 is 9. We find v2. We don't find the value of V2 because V2 is multiple with U double dash. What is the value of U double dash? 0. 0 to anything is always 0. Then to substitute all the value in the formula, therefore integrating of, what is our formula? U dV. We will be taking the value of U is 9x and all values are dV. So 9x into e power 3x into dx is equal to, in RHS what is the starting term? U. So U into V. The value of U is 9x into V. The value of V is e power 3x divided by 3. By our formula minus UV power minus U dash. What is the value of U dash? Is 9 into V1. The value of V1 is e power 3x by actually 9 plus actually next term is 0. So we integrate all the term. So lastly we have the constant C. Actually this formula is goes up to infinity. But this two term only possible, all the remaining terms are 0. So when we integrate the term, so you have the constant C. Now you see there is a chance to cancel. Is possible. So 3 times. So 3x into e power 3x. Here both the 9's are cancelled. Minus e power 3x plus c. So it is our answer. But in our simplification, you have any idea? You see in both the terms. Which one is common? E power 3x. So it will take outside e power 3x. So remaining first term is 3x minus. It will take outside fully. So 1 plus c. So it is the answer of the first one. So we must understand we using the sum by the concept of Bernoullis Formula. U dV. Important will be take the value of U is some x power and all the remaining terms are dV. Now we do the second one. This is some x sine 3x. So one term is x and another term is sine 3x. X sine 3x into dx. We do the sum also in Bernoullis formula. One term is x, that is x power, and another one is e power, instead of e power here sine 3x. By using this Bernoulli formula, I write the formula. You identify in this sum which value is u and which value is dv. We already say we will take the value of u, 1, 2 or 3 times differentiation, it become vanish. So the value of u is just x. And all the remaining values are dv, because our LHS is integration of u dv. So the value of dv is sine 3x into dx. I write only one line. What is the value of u dash? U dash means the differentiating of u with respect to x. X with respect to x is just 1. Okay. What about u double dash? That value is 0. So here we identify we need up to u dash. So we need up to v1. Okay. This part is over. Now we move dv. In our RHS term, v1 are in 1. But dv is there. In dv, how to find v? Taking integration. So taking integration on both sides, integration of dv is equal to integration of sine 3x into dx. Integrating of dv is v. What is the integrating of sine 3x? Integrating of sine 3x. Integrating of sine is minus cos. So minus cos 3x. I write whole divided by 3. How the denominator 3 will come? Is a composite function. First using the basic formula of sine. Again, we are differentiating this 3x with respect to x. We put the answer in denominator. So 3x with respect to x is 3. So is the value of v. Next, we need v1. In first sum I write elaborate. Now I directly integrate. v1 means the integrating of a v with respect to x. In this integration, this minus 1 by 3 is a constant. So I will take outside. What is the remaining? Cos 3x. What is the integrating of cos? Integrating of cos is sine. but cos 3x, so sin 3x, then by 3 using the same concept. Integrating cos is sine is a composite function. 3x with respect to x is a 3. We put the answer in denominator. So the value of v1 minus sin 3x by 3 3 are 9. Here also I find up to v1 because u double dash value is vanish 0. Next we substitute all this value in the formula. So integrating of u is x, dv is sin 3x into dx. Okay, LHS power. RHS starting term is u, the value of u is x, into v, the value of v is a minus cos 3x divided by 3. Wow. By our formula, minus uv minus u dash is just 1. Okay, u dash into v1. Again, the value of v1 minus sin 3x divided by 9. I write plus c because all the remaining terms are 0. So just 2 term plus I add c. How to write the first one? Minus x cos 3x by 3. Okay, plus and minus is minus x cos 3x by 3. In second term minus, here also one minus, so minus to minus is plus, just the number is 1, so the answer is plus sin 3x by 9 plus c. So it is the answer of the second one. The simplification is enough. Suppose sir common 3 is there, okay, we will take outside 1 by 3. Suppose we will take outside 1 by 3, then the remaining answer is minus x cos 3x plus sin 3x by 3. So that's also one denominator is there. So no need to take outside. So any one term is common, so we will be take outside. So it is the integration value of the second one. We move the third one. You see the term 25x e power minus 5x. Important is e power minus 5x into dx. 25x e power minus 5x into dx. The question will be asked in two ways. Integrate the following with respect to x or just evaluate. Okay, evaluate or integrate with respect to x. Okay, now we integrate the term. You see one term is x and the remaining term is e power minus 5x. In integration, x or x power something and e power something, better to use a Bernoullis formula. So here also we use the Bernoullis formula. Now you identify the LHS is integration of u dv. Which term is u? You identify the value of u is 25x. Sorry, here 25 is a constant, so I will take outside, okay. But important, this 25 is common in each and every term. So you must keep the bracket. So there is a problem will come, there is a chance. So I will take the value of u is within a constant. Or one way students are, I will take outside 25, okay. This answer is also correct. Suppose you will take outside 25, then what about u? Just x. But I will take inside the constant as it is. I will take the value of u is 25x. And all the remaining values are, this value is u, all the remaining values are dv. So the value of dv is e power minus 5x into dx. E power minus 5x into dx. What about u dash? We write only one line. 25 is enough. I write 25 into 1. 25 is a constant. X with respect to x is 1. So u dash is 25. U double dash constant alone. So the differentiating of the constant is 0. In RHS, how to come dv from b? Taking integration. So integral dv is equal to integrating of e power minus 5x into dx. So v is equal to integrating of e power minus 5x. E power minus 5x. Okay, whole divided by I write minus 5. Okay. The concept is first of all using e power formula. Again, we are differentiating the power term with respect to x. We put the answer in denominator. So the differentiating of minus 5x with respect to x is minus 5. So is the value of v. We need v1 also. For understanding purpose, I will take outside the constant. In standard form, minus 1 by 5, I will take outside. What is the remaining? E power minus 5x. The differentiating of e power minus, the integrating of e power minus 5x is again e power minus 5x imported by minus 5. We will take outside minus 1 by 5. The integrating of e power minus 5x is e power minus 5x by minus 5. The value of e1, numerator 1 minus, denominator 1 minus. Minus by minus is plus e power minus 5x whole divided by 5 is 25 is the value of e1. We find v2. No need of v2 because u double dash is already 0. Integrating of u 25x dv e power minus 5x into dx is equal to u 25x into v. The value of v is e power minus 5x by minus 5. Okay, uv power by our formula minus u dash 25 into v1 e power minus 5x whole divided by 25. I write plus c because all the remaining terms are 0. In fifth table there is a chance 5 times. In standard form this minus comes in numerator. So minus 5x e power minus 5x. Here we see both 25s are cancelled. 25 is cancelled minus e power minus 5x plus c. Now we see in this 2 term which is common. E power minus 5x is common. One more sign is also common. You see both the term lies within minus. So I will take outside minus of e power minus 5x. So I will take outside minus and e power minus 5x. What is the remaining first term? This minus e power minus 5x will be taken outside. Remaining is 5x. I put plus because we take outside minus. Plus all terms are taking outside plus 1 plus c. So it is the answer of the third. Now we move the fourth one. X secant x tan x. So integrating of x secant x tan x into dx. You see x secant x tan x. What is the value of a u? Same x. And all the remaining values are dv. So the value of u is x. And all the remaining values are dv. The value of a dv is secant x tan x into dx. I write only one word. The value of u dash is 1. X with respect to x is 1. What about u double dash? The value is vanished. 1 is a constant. We need a v, so taking integration. So integrating dv is equal to integrating of secant x tan x into dx. The integrating of secant x tan x is secant x. Okay, is the value of v, no problem. Next we need a v1. v1 means again we are integrating secant x into dx. We rarely use this formula. So the integrating of secant x is right log of modulus secant x plus tan x. I read this formula first time. The integrating of secant x is log of modulus secant x plus tan x. So how it is possible, sir? How to check? Is the answer actually. Suppose we differentiating the term exactly secant x will come, our answer is correct. First of all, log of modulus secant x plus tan x is 1 divided by secant x plus tan x is a composite function. Again the differentiating of secant x is secant x tan x plus the differentiating of tan x is secant square x. So if we take outside secant, denominator and numerator fully cancel, we get secant. So now the integrating of secant x is log of within a modulus tan x plus secant x. So we find up to v1 only because u double dash value is 0. Now we use this value in the formula. So integrating of u x v secant x tan x into dx is equal to RHS. First term is u into v, the value of v is secant x. By a formula, minus uv minus u dash 1 into v1 log of modulus secant x plus tan x plus c. All the remaining terms are 0. So x secant x, okay, x into secant x secant x minus just as 1 log of modulus secant x plus tan x plus c. Here we introduce one formula. The formula is integration of secant x. It's a new formula. Integrating of secant x is log of within a modulus secant x plus tan x. Now we see in first summation x log x. Now we integrate the term. So integrating of x log x into dx. Here Bernoulli formula is more complicated because we will take the value of x is u and all the remaining values are dv. We see the integrating of log x. The integrating of 1 by x is log x. Okay, the differentiation of log x is no problem, is 1 by x. But integrating of log x, we don't have the formula. So here I don't use the formula of Bernoulli. I use the first formula. In this class I already first tried the one formula, that is integration by parts. Now I solve this problem by integration by parts. The formula is integral u dv. LHS is same. RHS starting term is uv minus integrating of v du. Here also we will be taking the value of u and v is important. Now the integrating of log x is, we don't have the formula. So in this sum I will be change the value of u is log x, because differentiation of log x is you know very well. And all the remaining terms are dv. Integrating of x is also we have, so here the value of u is log x. I will take that log x is u. What is the remaining? X dx. I will take it is dv is x dx. LHS over integrating of u log x dv x dx. We multiply, we get the LHS. Now we find the RHS. In RHS, what are the terms are required? U, v. U is already there. V. So we integrate dv, we get v. Integrating of v, du. You see, one time du we find. U, we need du. So taking just differential of u. Du means the differential of u. What is the differential of log x? Differential of log x. First of all, 1 by x. The differentiation of log x is 1 by x. But with respect to no variable here, just we are taking differential. So log x formula is 1 by x. Again, the differential of x is dx. So the value of du is 1 by x into dx. Wow. In RHS, v, in integration also when v is needed, so taking integration. Integration of dv is v. Integrating of x is x square by 2. Using the formula of x power n. In integration x power n plus 1 by n plus 1. So x square by 2. So we don't find the v1, v2 like this, because in this formula v1, v2 term is not there. And also dv in du is there, so we find du. Now we substitute all the value in the formula. Okay, now we use all the value in the formula. Integration of, what is the starting term? U. We will take u as log x. Into dv. The value of dv is x dx. Over is equal to, RHS starting term is u. The value of u is log x. Into v. The value of v is x square by 2. Okay, first term is over uv. Next, minus integration of v du. Minus integration of v. The value of v is x square by 2 into, okay, du. The value of du is 1 by x into dx. So it is nothing but our given sum, okay? We multiply to what? X into log x dx. We don't multiply this x into x because this x is multiple with log. So x log x into dx. In first term, x square log x by 2, okay? X square log x by 2 minus, in integration, you see this x will be cancelled. We will take outside the constant also, minus 1 by 2. Okay, I will take outside the constant also. What is the remaining? In x square, 1 x is cancelled, remaining 1 x into dx. So x square log x whole divided by 2 minus 1 by 2, okay, minus 1 by 2. The integrating of x is again x square by 2. So we integrate, now we have the constant c. X square log x by 2 minus x square by, okay, minus x square by 2 to 4 plus c. That's is the answer. Here Bernoulli formula is impossible, so we solve the problem by integration by parts. Or Bernoulli formula is also, we use this method, but easy method is Bernoulli formula. In one or two sum, Bernoulli is complicated, we move into the integration by parts. Now you see term is common, x square. Suppose here also 1, 2 will be take outside x square by 2. Here will be take outside, suppose the common is x square by 2 log x minus, okay, 1 by, again 1 denominator term is there, so no need to take outside the common. So it is the answer of this sum. Okay, now in this class we see the two formulas. One is a Bernoulli and another one is integration by parts. We must understand when we use this formula in integration. In integration, these are the form some x powers and e power sum. The same model sums lies in one or two x's and example also. We must try in our class now.